What's going on, guys? Steven here, and today we're going to be doing a Leetcode question. Now, this is a question I've done in the past, but I don't remember how I did it, so I'll try and walk through it with you guys as well. Where is it? Expand tree, unique binary search trees. Leetcode number 96. Given an integer n, return the number of structurally unique BSTs. So we're given n, and basically if we had n equals 3, for example, we know by the term structurally unique means that 1, 2, 3 counts the same as example 1. Right here you see 1, 3, 2, right? So I noticed that. So the exact node you use for a position doesn't matter, but the positions you use up do matter. N equals 1, 1. Let's do another small case, n equals 2. We can do 1, 2. Or we can do 1. Also, let me set a 15-minute timer, or 17 minutes. I'll say we've been talking for 3 minutes. 1, and it can be the left child, right? And 2, 1, and 2, 1 here would count as the same thing. So we know that. Great. And so I'm thinking we keep the 1 at, for example, in example 1, I'm thinking we should just keep the 1 as the root and then try all the different positions for the next node. For example, we want to do some type of backtracking, and basically we start off with the root 1. When we have the root, for every node onwards from 1, 2 to 3, we can try placing 2 as the left child. And we can try placing 2 as the right child. No hints. So we would have 1. We try 2 as left child, go into 2, And we can either try 3 as the left child, or we can try 3 as the right child. Two. So we know these are right. Root equals 1. Yeah, I'm trying to think what I'm not thinking of. I like the idea of where we keep 1 as the root and don't try every node as the root, or and so on. But then if we do 2, we want to go down a path where 2 is the left child and where 2 is the right child. Then we want to know there's also a path where 3 is this, right? I feel like I'm missing something. This sucks. I promised I would post, even if I expose how dumb I am. Oh my goodness, let me not. Oh my goodness, what am I looking at? Well, that ant could have given it away. Dynamic programming. I think there's a top-down dynamic programming. Let's read a hint. Yeah, I'm getting stuck, guys. Suppose I want to know how many distinct BSTs there are with n nodes from 0 to n minus 1. If my BST has n minus 1 at the head, binary search trees. Structurally unique binary search trees. Why did I miss that definition? Great. This is what happens when you do a problem from the past and don't remember how to do it because you memorized the solution. So 2 So I kind of get the algorithm now. We just try every node as the root of the tree, and then we can see how many nodes will be to its left, to its right. And then we can do DFS of n minus two plus DFS of n plus 1, or no, sorry, DFS of oh yes, we got the algorithm, boys. I told y'all I would do this without looking at the solution. So for I in range 1 to n, count plus equals DFS of how many nodes on left plus DFS of how many nodes on right. Return count. Yeah, I think that's it. So if we have if I is 1, for example, how many nodes are on 1's left? I minus I, because there's 0 nodes. And if we do 2 minus 1, yeah, that works for I. Or does it? That's always 0. So how many, if I is at 1, that means we have it as our root, right? And we have 0. we have 2, we have 1 node. If we have 3, we have 2 nodes. If we have 4, we have 3 nodes to our left. Okay, that works. Now, how about this? How many nodes are on the right? That depends on, if we have 2, 3 minus 2 is 1, so n minus I. W, at least we got one test case, right? Never mind. So we have 4 instead of 5. Let me see if my algorithm even works on this. So 1, we have 0, 1, if 1 as a root contributes to 2 trees, right? So for I in range 1 to n, oh, that's why, n plus 1. Shit. Looks like we double counted now, but we do want to consider 3. Alright, let's just dry run through this because I know it's a simple mistake. These recursive problems, it's usually the one simple mistake that can fix everything. So considering each node as a root, then we do 1. How many nodes on the left? 0. 1 minus 1 is 0. Okay, 0 returns 0. Okay, plus DFS of 1, 3 minus 1. So we have 2 nodes on the right. If n equals 2, return 2. So count should be 2 from that. Okay, yeah, good. We're good with 1. What about if we choose 2 as our root? Count plus DFS plus equals DFS of 2 minus 1, which is 1. That returned 1. Plus it's not plus, clearly. It might be max. Good, I think we're going to get TLE. No, we're just going to get a wrong answer. Great. Oh, my bad. Well, what is it based on? Is it based on the max or? Let's do 2, and we have 4 nodes. So how many nodes can tree with root as to contribute to? 3, 4. So this right subtree. But what if let's say we had 5 nodes, right? And we had 1, 2, 3.
Someone was detected at your Martinez front door.
N equals 1, return 1. That is true. However, this tree What? If it's 2, we want to add them up though. DFS of... Okay, so I know we're doing the right DFSs. Three would be contributing 4 trees in this case. Because this could be like this, or it could be like this, right? And then these two, 4, 5, I'm tempted to just do a check for 1. So if both are 1, then we don't wanna. Otherwise, boom, boom, I got you, I got you. I know this is definitely not gonna be right. Of course. Yeah, I give up, guys. I think I'm just gonna have to look at my old submission. Actually, let's just get ChatGPT to give us a hint. Hey, how close am I? Uh, forgot multiplication. Oh my goodness gracious. And that is how many combinations it could contribute to. So if only I had basic probability skills, is basically what this thing is clowning me on. Wow. Wow, guys. I'm sorry. N equals 3, output 1. expected 5. And now I don't understand what's happening. What? Okay, guys, this is really sad. 1, return 1 times, but that becomes 0. Please, I can't take this anymore. So when you're doing plus, there's actually max and times. Okay. And that is just memoization. Cache equals n in cache, turn cache of n, cache of n, count, turn cache n. Great, we did it. I don't know how long that was, but thank you for sticking with me. At least I can say I didn't look at any code. That was about, let's do runtime first. Let's see if we can do runtime. Yeah, I don't think we didn't look at any code though. That base case I figured out myself. I thought the LLM tool was tripping. But yeah, the runtime is O of, is we're computing each state once, so it's O of n. Cache is O of n as well. Let's see if we're right. I believe we are, and of n. Oh my gosh. I'm gonna just end the video. Tomorrow I'll see you guys for becoming unchopped.